Got it. The meeting is being recorded.
The meeting is being recorded.
The meeting is being live
Streaming
streamed.
live.
Yeah, yes, we are now on YouTube.
I'm gonna
Live, it's alive.
You're all going to be muted. Me. Okay. Welcome everybody. Welcome everybody to the Kingston Center RASC October meeting. It's not clear outside, so glad you're here. For announcements, I just want to welcome one and all new members and returning members and those joining us from other centers on our Zoom, and we're streaming this live on YouTube. Just a reminder that we are having elections at our next meeting on November 10th, and the center needs your help. We have the secretary and the librarian positions that need to be filled as they are now empty, and the positions of president, vice president, and treasurer are up for election. So please consider one of these positions. The job descriptions have been in the last two Regulus newsletters. There are other positions that we have had that have not been filled. And if there is something that you would like to do for your center, please contribute and help run your center and let us know at kingston@rasc.ca. An announcement that was sent out to the email list this week, Astronomy on Tap is on Thursday, October 21st from 7 to 8:30 p.m. on YouTube. And now I'm not sure if David Levy has come in yet. He's here. David, would you like to do the introduction by poetry?
Thank you. Thanks, Kim, and it's good to be here. I would like to quote a poem tonight from Percy Shelley. One of the great romantic poems is a very short fragment to the moon, since the moon is now at our first quarter. Art thou pale for weariness of climbing heavens and gazing on the earth, wandering companionless among the stars that have a different birth and ever changing, like a joyless eye that finds no object worth its constancy? Thou chosen sister of the spirit that gazes on thee till in thee it pities. Thank you. Back to you, Kim.
Thank you, David. That was lovely. Okay, for our next upcoming part of the agenda, I don't see John here yet. Oh, he is here. Okay, John, would you like to give the members of the center an update on National Council meeting?
Hello. We had a council meeting at the beginning of last month, and they've not too much to report, but they have a new office. Details are available on the website, I believe, by now. It is just a few hundred meters from the original, one of the original offices they had going like 50 years ago. The roof doesn't leak, which the existing place does. So they're rather looking forward to that, and they hope to be into the new digs on January 1st. And then there's some discussion coming up about the future of GAs. They're hoping to get some feedback from council reps about what the membership would like to see in the GA, how much they'd like to see online or in person, go back to the old way, try to do some new combining of the two, that sort of thing. So if anybody has any feelings, what they liked or disliked about this last GA, what they'd like to see coming up, what if they haven't been to a GA, is there something that might get you interested in coming to a GA, whether in person or online? Please let me know if you have any thoughts on the matter. And if anybody has any questions or concerns, please let me know and we'll see what we can do. And that's it for the report at the moment.
Okay, thank you, John. Okay, so next we're going to go right into Hank's Sunspot.
Ah, I'm unmuted. There we go. Hello, everyone. I'm first. There we go. I now live in a place with 5 suns. I love it. Except it's cloudy anyway, so what does it really matter? Wait, my microphone's not down. That's better. Anyway, this is the last 3 weeks of September. This is Hank Sunspot from September 9th till today. And things have been not too bad at all. Sunspots are increasing, but unfortunately activity isn't really increasing really well, but we're getting there. How busy has it been? From September 9th to October 13th, there's been no X-class solar flares. Boo, everybody boo right there. 3 M-class solar flares with a 1.4, 2.8, and a 1.6. 2 of those were at times that we couldn't see them in this hemisphere or this part of the Earth. So that was really the pits. And 35 C-class solar flares. These are mostly produced by the 23 active regions from AR 12863 to 12885, with 885 just coming on board today. I didn't get on early this morning online, but I see by later in the afternoon it was listed. And the raw solar observatory imaging sessions this period has been 22 out of 30, well, 30 or 31 days, whatever it's been through the month. And the X-ray baseline is staying right at about 7 instead of 7.5 or 8 or below -8. So that's pretty good. And this
I was
was
just going to interrupt. Hank, do you have
Yep.
slides or images to show?
there. You're not seeing any?
You are not
Oh.
sharing
Hey, I didn't share. Why didn't somebody say that?
because you are so entertaining and so
Oh, crap.
verbally descriptive.
Hang on here. Now I gotta. Okay, now how do I downsize this now? Uh-oh.
Don't worry about downside. Just
There we go. No, I had to downsize it to see.
Okay.
I forgot to do the share thing. You know, it's become so automatic now. Oh man, I'm not gonna bore you with doing. I wonder why it works so well. Bore you with doing it all over again. Hang on a sec here. Okay. This is one to put in the books. And now, do we have a slideshow up?
I see Hank's and then that's it. So half of a page. How busy?
What? Oh, hang on. Why has it done that? Oh, we're doing good here, man. Okay, here we go. There we go. Now we're gonna get it.
Better, full screen.
We're looking so professional. How's that?
Looking good. Go ahead.
Looking good. That's the words I like to hear. Okay. So now you know what I meant when I said I live in a world with 5 suns now. And these are the 5 suns, but these are just 5 picks from the last 3 weeks of September, as I mentioned earlier. And it's been pretty good as far as especially H alpha. No really big flares, no really big prominences in particular, but some good activity and more sunspots, which gives you the bright active regions that you see in these images here. But as Charles Messier probably, I understand, found out about this time of year, there's more cloud. If you look to the lower left there, and the image on the lower right as well, it's a little more diffuse, and there's clouds going in front. It sucks this time of year. Okay, now I already said all this, so I won't bore you with it over again, but you can see that the baseline on the X-ray is pretty solid across 10 to the -7 and peaking up above. There are 2 drops there on those 2 days. The drops, if anybody doesn't know, is twice a year. The SDO satellite falls behind the Earth in the shadow of the Earth and shuts down for a short period, which is about a little over about 45 minutes by looks at 40 minutes thereabouts. So it happens in both March time, basically, and September, October time. I can't remember if it's March, April. Yeah, I think it's March, April, yeah. So what does all this mean with all this activity, but not as much activity? This is what it means. We are outperforming. We have more sunspots. We don't have a lot of flares, but as you can see here, the prediction from the NOAA NASA/NASA Cycle 25 prediction panel in 2019 said this is going to be kind of a blah solar cycle, and it's not going to go too high. Maybe you're looking at about 130 spots there maximum, you know. But here we are, where we were supposed to have about 20, 25 there, shooting over 50. So this is really good news. And it is also tending to push the peak ahead to late 2024 instead of mid 2025. Now, what I'm looking for there is not necessarily the peak. The peak is going to be earlier. That's good. But I want it to last longer as well. And hopefully that is going to be what is going to happen. It's not going to be quite the same curve as here. It's going to be a little shallower and longer each way. And we'll get a lot more solar activity because that's what we like if we're solar observers. And a little example of the sunspots that have been coming on. We have the 9th of September on the left hand there. And I can't see because the thing's in the way. Oh, it's 24th on the right. These are pretty good sunspots. They're looking nice. There's some good, decent plage, especially on the 9th on the left-hand side. But still, there's not a lot of activity is the problem. We're not getting a lot of solar flares of any type. And one of the things about not having as good as solar flares is we don't get those X, we don't get the Aurora, we don't get active, bright, glowing prominences and everything blowing off the sun as much. So I thought I'd try and do a little explanation about some of this. I'm not much on tech stuff, but I'm going to try here, just moving some things around. This is a page from Space Weather Live, and it's only I've only been going to Space Weather Live for a while. Kim and Kevin recommended it, especially Kevin. And I mostly do just spaceweather.com. And starting to go here and trying to understand more. I'm an imager. I like to take pictures, but I'm not as big on a lot of the technical stuff. And to try and get a little bit of it out there for those that might want to pick up imaging the sun or just understand what's being talked about. We have here on this is today's sun, and we have the sunspot number. And the sunspot number is 26. And everybody, well, most know that the sunspot number is adding up the sun regions, sunspot regions, and the individual sunspots. So this would have you believe on the left-hand side that the sunspot number is most likely, pretty well definitely, 2 regions, because you count 10 for each region, which makes 20. And then between them, they have 6 spots. But if you look over on the right-hand side, under sunspot regions, number of sunspots. Number of sunspots, don't let that be confused with sunspot number. You got to have your words in the right order and throw the of in there. The number of sunspots, 2882 has 4 spots. 2883 has 1 spot. And the new 2885 has 3 spots. Now, for me, that's 10, 20, 30 for the 3 regions. And then we add on 8, that makes 38. And over on the left, we have 26. So I'm not even going to go there to try to figure out where the other 12 went to. Kim or Kevin, well, Kim, especially a VSO on that, may be able to shed some light on that. But for now, that's where we're going. It depends. Then the class of solar spot, a sunspot, makes a big difference too. And as I bring down to the center in the bottom here, more than half of the observed sunspot groups receive an alpha or beta classification. As you can see, these 3 sunspots are 2 betas and 1 alpha. Where the bigger sunspots are often more complex and get a beta, beta gamma, or beta gamma delta classification, it is known well known that the delta spots can be very active and produce the most intense solar flares. And that's what we want. We want more active sunspots. Sunspots look nice, but we want the little extra that goes along with it. And at this point, we're not getting too much of that. But we're excited. We're waiting for it. It's going to build. It's going to get stronger. Now, up to the upper left here, there's a note here about that caught my eye, 10 to the 7 centimeter solar radio flux. Solar radio flux at 10 to the 7 centimeter, 2800 megahertz is an excellent indicator of solar activity. And this is really important because I have a friend named Kevin Kell who will message me and say, because he has an antenna, there has just been an X1 blast or an X2 blast or an M blast. And this is good because you're not always sitting down in front of the computer looking at the website. And you can get the alerts, but the alerts I find sometimes come 5 minutes later, 10 minutes later, or 20 minutes later. And in that time, the whole thing could have dropped off. But any more information about that? Ask Kevin Kell. He knows more than I do about that. The Carrington Rotation, I got interested in that and wondered just what it was, a particular type of rotation or something. But actually, in short, R.C. Carrington identified a rotation period, the rotation period of the sun to do one complete rotation, which is 25.38 mean solar days, and started counting them from November 9th in 1853. So this today, this is today's, the 13th, is day 2000, or rotation 2,249 since we started keeping count. There's some important to that, I'm sure, but to me, like I say, I'm just an imager. We're hoping for 2871 to come back around. You can see underneath that. 2871 at south latitude of 28. 2871 was a pretty good active little sunspot. And I didn't see any indication of it in the late pictures today. So maybe it may not happen. It may have totally diffused and died out. The size of sunspots. The size of sunspots, the area of the sunspot group is expressed in millionths of a solar hemisphere. Now, I would have thought it would be millionths of the whole face of the sun, but it's the north or south hemisphere. The sunspot groups cover an area usually about the size of the Earth, which always impresses people if you're doing any public observing or anything like that, to tell somebody that that little black dot you see there is actually about the size of our entire planet. I find it often completely blows them away that we can be consumed within that tiny spot. But the larger sunspots, which were, pardon me, the Earth is 170 millionths of a hemisphere, but the larger ones can go as high as 1,000 and more. That's what we had back in 2003. They were absolutely stupendous. They were huge, and certainly looking for that to come again. There's also the table of characteristics of sunspot regions, and I tried to look at this Zurich Macintosh system, and all I can say is, if you're interested, take that Space Weather Live page right there and go look at it, because it's far too complicated for me. So anyway, in a nutshell, this is extra data to learn a little more about the sun and know more about what you're looking at, other than just taking pretty pictures and rolling them over and putting them on Facebook pages, etc.
Hank,
yes,
it's Kim.
yes, I know.
The Macintosh classification is all about the magnetics of the spot.
Yes. That, I thought I had that in there, but I think I must have either put it up too high. Yeah, the magnetics of the spot, and what the actual explanation was a little something I don't know, I can't get into, but it is really important because the more intense the magnetic field, the more these spots show up, like what you could call sunflowers or whatever, with magnetic fibers going in all directions. And it does make them incredibly beautiful, especially if you have the ability with a good scope and a good camera to get in close, a good tight image. And I'm hoping to see you do that someday soon, Kim. And yeah, it's thank you for that little added information. I forgot about the magnetic characteristics on that.
One thing that I would like to add to your report is that I just looked at the sun about an hour ago and I saw the great big spot, but between the spot and the limb of the sun, I saw a fairly decent flare today.
Oh,
It wasn't
good.
in white light, it was in alpha light, but I did see that flare just about an hour ago.
Well, that's good. I never managed to get out today, and then it clouded over later in the day, but this morning and around lunchtime, it was fairly clear, but I was too busy. Schedule kind of got to me and I never got there. So glad you got to see that, David, and thank you for reporting it for sure. Now, these are just a couple of images from the 8th of October, and this is a comparison side by side of the H alpha and the white light. When the spots start to get a little bigger, I feel between the plage and the white light, they actually start to compete more. When the spots are very small or even not, or especially non-existent, H alpha just blows everything away. But once you get into good, decent sized sunspots and groupings and plage and pick up on the granulation, they can really compare with each other, and really white light is a great thing. So you don't have to buy an expensive telescope to like a solar Coronado or a Lunt or a Quark to do the H alpha and still do really decent solar imaging. Get out there and try solar, use some beta film. And this image on the right is butter film with a 120 millimeter Skywatcher, and it picked up some quite good detail there. I think this is with a DSLR. With a digital camera like an ASI or something like that, you would get in a lot tighter and get much more of the magnetic fibers around this sunspot around 2882. But even if you're not looking at doing that, still take a try at it. And as I said earlier about sunspots and the X-ray activity and all that and radio, yeah, here's an example right here. It was 6:19 in the morning that after these images that there was an M1.6 solar flare while I slept. It was 2:16 our time. And sometimes you just don't get there. You know, you only have that small window. And then this time of year, that window is a lot smaller, with the daylight getting shorter and shorter. And this is something that many saw last Wednesday. And I hope that if you look at this, you're seeing a little dot going across the screen from red slash to red slash. Some of you were not at the chat, so I put this up again. And that is the Tiangong Chinese space station transiting the sun. I am not the best at this. I've only done this a few times, and I've now changed my camera settings to 59 frames per second to try and get a smaller, sharper image. And I'm sure it won't be enough to get it really clear, but I hope you can see it going across there. And look for these solar transits on transitfinder.com. This is something any of you can do. It is really incredible. And the space station in particular, with the eye, never mind a camera, just set up, watch for it. It goes, but this one was 66/100ths of a second. The first one I ever did was from Kim and Kevin's front driveway. It was the space station. And in 0.6 of a second, about the same time, it just ran across the view like it was a little bug shooting across. And it was one of the most exciting things I've ever seen with astronomy. So that concludes what I have for tonight.
Thank you, Hank. It was awesome.
Well, thank you.
Yeah, there was no sun observing today at all. I mean, there was little sucker holes. So by the time you get out there and open everything up, it would be covered over again. I did that all yesterday afternoon was like that.
I haven't been out much in this last week here.
Yeah.
And yeah, it's not pleasant to have this increased cloud
No,
and haze
that's for
and
sure.
the haze.
And the haze, yeah. Okay, thank you. Anybody have any questions for Hank? No? Okay, well, let's move on to Rick Wagner to show us what's up in the sky for October.
All right. Here we go. Our sky this month, October already. It still feels like September. So RASC and local events, the 16th of October is not exactly local, but International Observe the Moon Day. If you do a search on International Observe the Moon Day, you'll find links to some of the events. I think Montreal Center's having something in the afternoon, and I can't remember who else. Fridays, the Queen's University Physics Department seminars are back. I said here in person, but I see now that some of them are Zoom, some of them are in person. And there are 2 scheduled for this Friday and next Friday. And there's a name attached to one of them, but no topic for either of them. But I did, or no, I think there's names attached to both of them, but no topics. So I followed up who the people are, and they are both astronomy type people. So we should expect some decent astronomy seminars. One of them is a Zoom, and the other one I think is in person. And the observatory, Queen's University Observatory's got another new fast radio burst podcast up on all about Earth extermination. We all like to know about that. The BAA events, well, they're doing their live moon observing on the 13th. And it's kind of nice because of the time change, we get to watch it at 2 o'clock in the afternoon. On the 16th of October, RAG-21 Day. I don't know what RAG stands for. But anyway, starts at 5 o'clock in the morning.
Radio astronomy.
Oh, okay, radio astronomy group. All right, so from 5 o'clock in the morning till noon, and I think there's a limit of 100 people who are allowed to register. So if you want to attend that, you'll want to register well in advance. On the 23rd of October, they're having their annual general meeting, most of which is going to be really exciting business stuff, auditors' reports and all that kind of stuff. But starting at 11:30 our time, they do have a couple of paper sessions. And on the 5th of November, the physics, analysis, and imaging of solar flares presentation from their radio astronomy group. AAVSO has only one webinar in the coming month on the 23rd, well, 2 of them, how to write an astronomical research paper, and another one on dark and quiet skies about a UN effort at light pollution. They would normally have one, I think, on the 6th of November, but that's their annual meeting and so forth. So they won't have one that day. Our daylight and nightlight times. You can see from the chart for the 21st of October, things are split about almost evenly now. 10 hours and 2 minutes of astronomical darkness, 10 hours and 42 minutes of daylight. And by the end of the month, it's balanced in the dark observer's favor. We get up to 10.5 hours of darkness, only 10.25 hours of daylight. Up in the sky for the rest of the week or so, if you get up early in the morning, you should be able to see the zodiacal light in the eastern sky before sunrise. Very quite faint triangular light extending up and to the right from the eastern horizon. If you get out near midnight, you should be able to see the, or might be able to see the Gegenschein if you've got good eyes and good skies. 13th of October, that's like today, first quarter moon, and the moon is just south of Saturn. On the 16th of October, I think it might be quite interesting to look at. Brilliant white Venus will be near the reddish star Antares in the southeastern sky during the evening. Full moon on October 20th. And the very next morning is the Orionid meteor shower. So with a full moon in the sky, you won't expect to see nearly as many meteors as you normally would. And also on the 21st, the moon is just going just a little ways south of Uranus. So if you get out at the right time, that'll be a good guide to help you find Uranus. It'll probably make it somewhat more difficult to see, of course, but it's about 6th magnitude anyway, so it'll point you the way there. 25th of October, Mercury will be at its greatest elongation west, 18 degrees west of the sun. So that'll be its best morning apparition of this year. And also on the 25th, Algol will be at minimum brightness for about 2 hours, centered shortly before midnight for anybody who wants to try some beginner photometry or variable star observing, because of course you can do it visually. 28th of October is the last quarter moon. 29th of October, Venus is at its greatest elongation east. So that'll be in the eastern, or the western sky rather, after sunset. And early November, to take us through to the next meeting, the 3rd of November, thin crescent moon, Mercury, and Spica will all be within one binocular field of view together in the eastern horizon just before sunrise. That might be quite attractive. And middle of the late-ish afternoon that day, the moon is going to occult Mercury. So that'll be a challenging observation. Mercury, as it says above, about minus 0.8. So it should be visible during the daytime with a telescope. It'd be interesting to try that. 4th of November, a new moon. Late in the afternoon, Uranus is at opposition at magnitude 5.7. So it's a good chance to get out and try and see it naked eye. Not very many people have seen it naked eye. And starting on the 4th of November, we get into another period when it's relatively moon free in the morning sky. So a good chance to look for the zodiacal light. And the 7th of November, daylight saving time ends. Hooray, hooray. And the crescent moon will be near Venus in Sagittarius. And that's all I had. There were essentially no interesting asteroid events this month at all. So, any questions?
None. Thanks,
None.
Rick. But
welcome.
there's going to be some observing happening. We just need the clear skies. That's all we need. Yep. Okay. Carrying on, we now have Kevin, who has got quiz time. Oh, we need a paper and a pen, he says. Okay. Everybody get your paper and pen out.
How to describe the feeling that this is antique and that I'm an old fogey that demands that you get paper and pen. You can use a pencil too. We are trying these out. This is an old quiz for you to have some fun with. And if anyone else on the call would like to put together some questions, and somebody who's great at quizzes by the name of Hank, I think it was. Hank has put through many quizzes in his lifetime, but anybody else as well. It's fun. It's fun. So while we're waiting for people to get pen and paper, I'm just going to quickly show the Aurora that we had last 2 nights ago, the 12th. And you see that little teeny itty bitty little light on the horizon way up in the north from our latitude of 44 degrees? That is Aurora. Oh my God. Everybody goes, yay, Aurora. Wasn't very impressive. Ran from about 2 to 3 a.m. Eastern Daylight Time, but it's a start, right? It's a start. Okay, so let us pull up the quiz. If you remember, many long times ago, we did an astronomy course, observational astronomy for the novice, OAFTN, aka the NOVA course that the RASC put out years and years ago. So this is a multiple choice quiz, and it's just intended to let you know, think how you know you were doing in this course that we ran in 2005. Answer each question with the best or most relevant choice. No references. This is all about what is in your brain right now. And you'll need paper and pen to record the questions and the answers. There's 18 questions, and then we'll quickly go through them afterwards. We're going to try to keep it moving pretty quickly. So 20 to 25 seconds per question, with the exception of one question that has a lot of numbers in it that may scare you away. Don't be scared. Just think when you're doing multiple choice quizzes. Obviously, there are some answers that are totally wrong. You throw them out. There are some answers that are absolutely right, and you know that right away. And then there's those ones in the middle. And if you can weed your way through those, that's how you do a multiple choice quiz. So, Madam President, do you have a piece of paper and a pen? And are you ready? She is. Let's go. Question number 1. This is in the general observing section. What is the best location to observe from in the following list? A, the parking lot at Canadian Tire at Princess and Gardner's Road in Kingston, where they turn the lights off at night. B, Lemoyne Point Conservation Area. C, Murney Tower Museum Waterfront Park. Or D, the Queen's University Ellis Hall Observatory. I don't see anybody writing down answers. Oh, there's somebody. Oh, all right, maybe they're just all faking it. Okay. That one was pretty easy. Let's go on to question 2. Which is the least useful item for nighttime observing? A, a red flashlight. B, a red pen. C, appropriate clothing. Or D, a TV tray or table. There's some people going, oh, I know, I got that one. Not a problem. Okay, they're going to get harder. Question number 3. What is the most useful piece of information to put down in your logbook for an observing session? A, what TV show are you missing right now to be outside? B, how deep is the snow you have to shovel to get to your observatory? C, the date, time, and what you looked at. Or D, what you looked at, the date and time, and the sky conditions. I see a few grins. Okay, this is good. Try to make this humorous. Moving on to the next question. Question 4, looking down on the Earth from the North Pole, does the Earth rotate? A, clockwise, B, counterclockwise, C, top to bottom, or D, bottom to top? I see people's brains engaging. This is good. Okay, let's move on to the next one. Question 5, you are an observer on Wolf Island looking north. Which direction does the North Star move? A, up, B, down, C, left, D, right, or E, nowhere? Okay, moving on to question number 6. Oh, we're in the section 2 of called Motions in the Sky and Seasons. That gives you any hints or help. Number 6, the sun is located near Sagittarius. What season is it? A, summer, B, spring, C, winter, or D, fall? Okay, now I'm getting some faces that are going, what? I am unmuted, right? Yes, okay, yeah, just checking. The sun is located near Sagittarius. What season is it? Okay, let's move on to question number 7. 5 magnitudes of brightness difference is how many times brighter? A, about 99 times, B, about 100 times, C, about 101 times, D, 100 times, or E, 5 times. Okay, so if you're not sure, take a guess. Question number 8, we're into maps and brightnesses. Describe in numerical format the location of a strange object you saw last night around 10 minutes to 9 p.m. in the northeast, about 1/3 of the way up from the sky from Enterprise, Ontario, while your feet were pointed northwest and a planisphere in your left hand dialed into Sagittarius on August the 3rd. Okay. A, 44 degrees, 22 minutes north by 76, 15 minutes west at 2050 EDT, October 4th. B, 30 degrees azimuth by 45 degrees altitude at 2050 EDT, October 24th. C, 44 degrees, 22 minutes north by 76 degrees, 15 minutes west at 0050 UT, October 25th. Or D, 30 degrees altitude by 45 degrees azimuth at 2050 EDT, October 24th. So this is the one I said that had a few numbers, and maybe we'll spend a little bit more time trying.
What happened to none of the above?
The answer is not none of the above. The answer is A, B, C, or D.
Mine is.
So again, look to the core of the question. Describe the location of a strange object you saw. We may have to come back to this one because I can hear gears grinding without oil or lubricants right now, and I see a little bit of smoke coming out too. Okay, well, we'll maybe come back to this one at the end if anybody requests it. Question number 9. What is a planisphere? A device to smooth wooden spheres. B, a moving star chart that can be set for specific locations but not time or date. C, a moving star chart that can be set for dates, times, and locations. Or D, a fixed star chart that you can hold up in the direction you are facing. Ooh, this one looks like it might have a few possible answers. But there's only one correct answer. Okay. Let's move on to question number 10. We are now into telescope types. What is a useful rule of thumb for how much magnification a telescope can use? A, 10 times per inch of aperture. B, 100 times per inch of aperture. C, 50 times per inch of aperture. Or D, 625 times per inch of aperture, as seen in your department store telescopes. Okay, moving on to question 11. Which of the following is not a property of a Newtonian telescope on a Dobsonian mount? A, generally less expensive than a Schmidt-Cassegrain telescope of equivalent size. B, generally large in physical size than a Schmidt-Cass telescope of equivalent size. I'm not even sure if I understand that answer. C, can track the moving sky better than a Schmidt-Cass telescope on an equatorial mount. Or D, faster to set up in the field than a Schmidt-Cass telescope. So which of the following is not a property? So basically, these are all things that we covered in the course that we were teaching beginners, and they wanted to know how they were doing, so we gave them a quiz. Moving on to question number 12. If the focal length of your telescope is 2,000 millimeters and you are using a 50 millimeter eyepiece to look at the moon, what is your magnification? I love math questions. A, 4 times, B, 40 times, C, 400 times, or D, 625 times. As seen on your local departmental store telescope. Okay, I think everybody's got that one. Number 13, we are now into stars, RA deck, and deep sky. In general, in what order are the Greek alphabet designations of the three brightest stars in a constellation? A, alpha, beta, gamma. B, gamma, delta, alpha. C, beta, gamma, alpha. Or D, alpha, beta, epsilon. I forgot, what was Animal House's fraternity? Party, party, party? I'm not sure. In general. Okay, moving on to question 14. Which of the following is not a deep sky object? A, Pluto. B, M31. C, the double cluster in Perseus. D, the globular cluster M14. Okay, everybody jotted that answer down real quick. Going on to question 15. You were in your dark sky backyard last night observing and saw a naked eye deep sky object high overhead in the north around midnight. What was it? A, M57, the Ring Nebula. B, M31, the Andromeda Galaxy. C, Mars. Or D, Ceres. Okay, moving on to question 16. We're almost done. We're getting there. When can you best see a new moon? Oh, this is a great question. A, when the moon is highest up at midnight. B, a few days before or after a new moon. C, when it is rising at sunset. Or D, when it is setting at sunrise. I can see some logical arguments forming on this one, but just go for the simple stuff. Go for the simple stuff. When can you best see a new moon? Of the four answers. Okay, let's move on to question number 17 in the moon and eclipses section. An annular solar eclipse is when A, the moon completely covers the sun. B, the earth is between the sun and the moon. C, the moon covers only a partial portion of the sun. Or D, the moon is completely inside the sun, but is smaller than the sun. Okay, that was an annular solar eclipse, and apparently we're going to be having one in 2023 before the big event in 2024. Last question. During a total lunar eclipse, why can you see the moon if it is in the Earth's shadow? A, because the moon has an atmosphere. B, because light from the sun bounces off other planets. C, because light from the sun refracts through and around the Earth's atmosphere. Or D, because light pollution on the Earth's night side illuminates the moon. Okay, so everybody feel free to unmute yourself. Does anybody want us to go back and cover any quick question a second time? Otherwise, we will go through the answers real quick.
After the question about wine.
Family PG audience, no wines allowed.
Oh, okay.
Okay, here we go, folks. Number one, what is the best location to observe from? Answer B, the Moyne Point Conservation Area, because A, C, and D all have high levels of local light pollution. Yes, the Canadian Tire parking lot does turn its lights off at night, but there are so many other businesses around it that do not. Murney Tower is right downtown. Ellis Hall Observatory is right downtown.
Well, I'm allowed to get that one wrong because I have no idea what the conditions in Kingston are like.
You are absolutely right, Mark Cody. Question number two, what is the least useful item? B, a red pen, because you can't see red ink and red light. Everything else there is more useful than that. So again, hopefully you learn something and not take out a red pen, even once. Number three, what is the most useful piece of information? The answer is D. C is close, but D is closer.
Oh.
So what you looked at, the date, time, and the sky conditions over the date, time, and what you looked at. So again, you could call this a little bit of a trick question, but that's the nature of the exercise.
Well, I'm 2 out of 3.
We're going to hope to migrate this to an online electronic platform once I can find one. And they have time limits and buzzers and scores and statistics, all this stuff, but so far no luck. Question number 4, looking down at the Earth from the North Pole, does the Earth rotate? Answer is B, counterclockwise. So you look down at there, the sun rises in the east. So the Earth has got to be rotating into it. That one was a little tricky because your mind always goes, what? Question number 5, you're an observer on Wolf Island. That's just south of Kingston for those who aren't local. Which direction does the North Star move? The answer is E. That does not move much. Okay, yes, it may move a little bit, but not as much as up, down, left, or right. Again, yes, it's subject to debate. Number 6, the sun is located in near Sagittarius. What season is it? The answer is C, in winter. Sagittarius is a summer constellation. If the sun is near it, it must be winter. God, I hope that answers right.
Yes, it is.
Any feedback out there? Yes, thank you. Question number 7, 5 magnitudes of brightness is how many times brighter? The answer is D. The definition is exactly 100 times. So A, B, and C are all close, but no cigar. Question number 8, describe in numerical format the location. So the answer is D. Altitude, azimuth, and time are the important bits. And so 30 degrees high is about 1/3 altitude, northeast, about 45 degrees altitude. So you're trying to tell other people what you saw and when, and these are the important bits of information. The C is your local location, which doesn't really have too much bearing on this for a local event. Again, we're a Kingston class of people. And how come B didn't answer? 45 azimuth, 2050. Are B and D the same answer? No, azimuth and altitude are switched. Okay, tricky. Moving on to question number 9. What is a planisphere? The answer is C. It can be set for dates, times, and generally locations. Planispheres come in ranges of latitude that you can purchase. So that's what I meant by locations. Answer is C. Question number 10. What is a useful rule of thumb? The answer is C, 50 times. I should say for visual observing too, because imaging with cameras is so much more popular now. Question number 11, which is the following is not a property? The answer is C. It cannot track automatically, and manually moving requires 2 motions. Everything else there is a property. It's generally less expensive, generally larger in size, and faster to set up. B should probably say something like equivalent price, not equivalent size, because that's, well, an 8-inch Newtonian on a Dobb mount is still bigger than an 8-inch Schmidt cast. Yeah. Question number 12. If your focal length of your scope is 2000 and you're using a 50, what is your magnification? Magnification is focal length divided by eyepiece is 2000 divided by 50 equals B. 40 times. I'm starting to lose it. Question number 13. Sorry. Yep.
You've already lost, Kevin.
Oh, thank you. There you go. Question number 13. In general, what's the order of the Greek alphabet designations? The answer is A, alpha, beta, gamma. And I discovered this all on my own one time when one of the stars in Scorpius, which was supposed to be a bright star, turned out to be a variable and went dimmer than the other stars that were designated beta and gamma. I think that was the one. Yeah, it was fascinating. Wow, I discovered something all on my own. Question number 14. Which of the following is not a deep sky object? Answer is A. Planets are not deep sky objects by definition.
Neither are dwarf planets.
Yeah, well, we're not going to get into that debate because we have a contract out on Mike. Sorry, never mind. Question number 15. You were in your dark sky backyard last night. The answer is B. M57 is not a naked eye object. Mars and Ceres are not deep sky objects, as established in question 14. So the answer is B. M31, the Andromeda Galaxy. Question number 16. When can you best see a new moon? The answer is B, because A, C, and D are all full moons, and B is the nearest to a new moon. So when the moon is highest up at midnight, that means the sun is opposite it. And that means it's a full moon. When is the best out of those four answers? So, and when it's rising at sunset, it's a full moon. And when it's setting at sunrise, it's a full moon. So there we go. Trick questions. You have to, twist your brain a little bit. Annular solar eclipse is D. The moon is completely inside the sun, but is smaller than the sun. A is a total solar eclipse, B is a lunar eclipse, and C is a partial eclipse. Okay, last question. During a total lunar eclipse, why can you see the moon if it's in the Earth's shadow? Answer is C. Sunlight refracts through the Earth's atmosphere and lights up the dark moon. And if there happens to be a volcano like Mount Pinatubo in 1993, you can't even see the moon. It disappeared. Okay, well, that took away 25 minutes of your life that you'll never get back. Hopefully you enjoyed it. And as I said, if anybody has any interest in this kind of thing whatsoever, please go ahead and make some up, and we will try them out in future meetings or newsletters or weekly socials or wherever we can. And that is all Kevin has for you.
Thank you, Kevin. Now that our brains hurt.
That was fun, but I sucked.
Okay, so this evening we did not have any, I guess, speaker, as you can see. So we have got our own speakers up, but now we'll open up the floor for if anybody wants anything to present, if they have something they want to show, a picture, or have any topics. Now is the time. And then go ahead, Mark.
I just have a quick bit of news. I'm going to be the new vice president of the Peterborough Astronomical Association.
Good for you.
Way to go.
You're getting to be a busy person.
And I told them no more meeting agendas.
No more meeting agendas.
Well, just that the current president, who's been there for 4 years, kept sending out agenda after agenda after agenda, and they always had to be revised. And I said, you want something, let me know, and I'll post it.
That's okay. I understand now.
So Kevin here, this is a perfect opportunity to do a speaker exchange with Peterborough.
That's right. We can do that. Mark, you and I will talk. Okay. Nobody has anything. It's going to be a very short meeting tonight, folks. Unless somebody has something that they want to present. Oh, Peter says, great quiz. Oh, Susan has something. Yes, Susan.
I would just like to say that Mark K's observatory, after his new carpeting going in, looks tidier than any corner in my house, and it's lovely.
It's the old carpet still. It's not new.
Oh, you're just getting ready then.
No, I was thinking of doing it. I'm not.
He
I'm
just
not ready
cleaned
to-
it. He
Yeah.
just cleaned it.
Actually, no, everything is behind the pier over here. You can't see it.
And this may not be an observatory, as I do not see any telescopes. This may be a studio. And there goes that theory.
There we go. Just fits.
That's-
That is snug.
Tight.
Beauty.
Tight.
Excellent.
Are you
Do you have
worried
to
about
grease it to get it in there?
contraction and expansion during heating and cooling?
Yeah, and I hit my head on it all the time.
Oh.
I
Guess it's
found I used to hit my head on mine and I drape a sheet over it. And
Now
that
you
way
hit the sheet.
it hangs down low enough in front of your face so you don't walk into it anymore.
Yeah.
Or you're just going to
Try
have
that.
to wrap it in that pipe wrap. That's the foam.
At Lowell Observatory, they have a boxing glove on the end of where the counterweight is, and it saves people from injuring themselves.
Sounds like they've done it before. Okay. All right. So our last slide for the evening then. If nobody else has anything, we're going to be closing up shop pretty soon here, but I have a few more announcements. Just a reminder of our November meeting. We'll have our annual meeting at the beginning, then we'll have a regular meeting at the end. And I believe, Rick, were you going to speak in November?
Yes, I can probably do that.
Okay. Put you down. And just a reminder that we have our weekly socials every Wednesday night at 7 p.m. And Susan looks after that and she sends out the link every week. And if you're not a member, for those people that we have on YouTube or who are joining us, if you're not a member, there are benefits of joining the RASC. There's the Observer's Handbook, Electronic Journal of the RASC, the observation programs, Sky News, Regulus for the Kingston Center, local email list, which is full of fun and fascinating topics. And yes, there is astronomy as well. And our local library and e-library, which has been updated as well from Francesco. You can catch this meeting on YouTube once it's compressed and up and closed off for the night. And we're on Twitter and we're on Facebook. And are there any other questions? And we can close our YouTube event. Good night, everybody on YouTube. Thank you for joining.